There's basically a lot of confusion. There's a lot of confusion in terms of what is machine language and what is machine code. There is a lot of confusion over there, and if you're starting now with the programming, with coding, and you're trying to find out what is what, and you're going through the forums, you're gonna go crazy. So this is why I'm going to do this video to make it as clear as possible and as simple as possible. So basically, many people are trying to say that computers are um, responding to machine language, and machine language is zeros and zeros and ones, which is absolutely wrong. Machine language has nothing to do with zeros and ones. All right. Let me go back to my previous video, which was about bits and bytes. I was just explaining how 1 byte consists of 8 bits and how you can actually construct everything from 8 bits. All right. So there's this ASCII table where you can construct number, which responds to a certain letter. You can also construct numbers as well. You can construct everything with this table, right? So basically, you can write anything with zeros and ones. You can write anything, as you can see. You have all the numbers and all the letters, all the alphabet letters you can display with zeros and ones. Everything. This doesn't mean that computer will understand it because uh, many people, allegedly smart people in the forums, say, "Oh, machine language is zeros and ones." No, this is only the representation. You can write anything, virtually anything with zeros and one. You can write the whole Shakespeare novel, or like a piece from Shakespeare, you can write in zeros and ones. That doesn't mean that the computer will understand it. This is not a language. This is not a language that a computer understands. The computer understands a specific language, which is a machine language, um, which is, for example, it says it's talking to the CPU, right? And it's instructions to the CPU. It's telling to a specific CPU register, you need to add this value. Then it says you need to fetch the memory location that registry is the address of. Then you need to compare the two registers. Um, for those of you who don't know, register is like the memory of the CPU. So you're talking to the CPU, right? You need to give instructions to the CPU. That's the whole point of the machine language. You have to give specific instructions to the CPU. That's the language the CPU understands. That's the language, all right? And if you write, let's say, War and Peace, the novel from Tolstoy, in binary, the CPU will not understand it, of course. There's nothing the CPU can do with it. So basically what happens is there is the high level language like Java or C++. Then there is the machine language, the assembly language, which is in between. And then there is the machine code, which is just binary, nothing else. The machine code is just, you can convert anything into a machine code, into a machine, into binary, you know? So this is what I found here online. Everything is fine, except I wouldn't call it a language. It is zeros and ones. It's not a language. It's just the code that is coming from, you just converted this assembly language to binary. All right, that's all. So it's the high-level language, for example, Java or Fortran. There is a compiler that makes it look like this. This is here. This is the machine language, guys. This is how the machine language looks like. These are instructions for the CPU, for the processor. All right, this is how it looks like. You're talking to the CPU. This is the language that the CPU understands, you know? This is what the CPU understands. So there is one more assembler, and then it puts it into machine code. But you can put everything into binary, you know, it's just binary. Doesn't mean that everything that is written in zeros and ones the computer can understand. That's bullshit, you know. You can write everything in zeros and ones, and the processor will not know what to do with it. Like, um, so just to make sure you understand what CPU is consisting of. It consists of control unit, um, arithmetic unit, um, arithmetic logic unit, registers, which is the which is the a quickly accessible location available um, to a computer's processor. Um, this is like a fast storage. You have modern CPUs have also cache, and CPUs have a clock. So this is your partner that you're talking to. This is the piece of hardware that you are giving instructions to. So you have to speak its language, you know. It's just the machine code is not like, oh, machine code is just zeros and ones. But what kind of zeros and ones? That's the point. What kind of zeros and ones is the machine code? You know, like I said, you can convert anything into zeros and ones. It doesn't mean that the computer will understand it. All right. So that's very important to understand what is the three steps: high level language, machine language, and then the machine code. All right, the machine code. The machine code and the machine language is not the same. Machine code can be anything.